Welcome back to our channel Xfinity, where we bring you the latest news and discoveries from the world of science and space. In today's video, we will talk about a stunning cosmic event captured by the James Webb Space Telescope.
A stunning new image from the James Webb Space Telescope shows a supernova hosting galaxy not once, not twice, but 3 times at different points in time. This seemingly time-defying image by the James Webb Space Telescope, JWST, was possible thanks to the massive gravitational influence of a foreground galactic cluster in a light-bending phenomenon predicted by Albert Einstein over a century ago called gravitational lensing. In his theory of general relativity, Einstein predicted that mass warps the very fabric of space and time, or spacetime. This is analogous to placing a ball on a stretched rubber sheet, with the ball causing a dent in the sheet. The greater the mass of the ball, the larger the degree of warping it causes. This is also true in the case of spacetime. Stars cause a greater warp than planets, and galaxies cause a greater warping of space than stars. This warping affects the passage of light as it travels past the object of mass from a background object. In extreme cases, because light can take different paths around the lensing object from the background lensed object on its way to us, it can cause the background object to be magnified or even appear at multiple points in the sky. That means this phenomenon, gravitational lensing, has become a powerful tool for astronomers in studying very distant objects. The lensing object in this new JWST image is the galactic cluster RxJ2129, located around 3.2 billion light-years away in the constellation Aquarius. RxJ2129 is lensing a background red-colored supernova hosting galaxy replicating it. The supernova explosion was discovered by astronomers using the Hubble Space Telescope and is a Type Ia supernova designated a 2022 RIV. These are often referred to as standard candles by astronomers because of how uniform their light is. This uniformity means that Type Ia supernovas can actually be used as a tool of measure cosmic distances because at the same distance, they would look exactly the same. As a gravitational lens, RxJ2129 has created 3 images of this galaxy that aren't the same in size, position, or even age because of the different paths the light from the background galaxy takes and thus the different times it arrives at the JWST. The light that follows the longest path shows the background galaxy at its oldest age and at a time when its supernova was still occurring. The next image from the second longest path shows the galaxy just 320 days later, and the last one with the shortest light path 1,000 days after the first. In both of these later images, the supernova at 2022 RIV has already faded from view. Also appearing in the upper right-hand corner of the image are several background objects that due to the warping effect of gravitational lensing appear as concentric arcs of light. The observations were made by the JWST using its near-infrared camera, opens in new tab, NIR spec, which was able to measure the brightness of a 2022 RIV, a very distant and thus early supernova. The powerful space telescope has also been to perform spectroscopy on the light from the event, which should allow this distant supernova to be compared to more recently occurring Type Ia supernovas in the local universe. This comparison could be used to test the accuracy of using these supernovae when measuring distances, thus verifying the results of one of astronomy's most useful tools.